Good morning, friends. In the last period, we have to studied about the solar cell fundamentals. In that, semiconductor devices and PN junction we have studied in the last lecture. Now, third solar cell fundamental is very important. Today we are going to discuss here. That is VI characteristics of a solar cell. In the VI characteristics of solar cell, that is, we have to consider here one more solar cell. In the solar cell, we have to consist of a two junction semiconductor, that is N type and P type. N type is a very thin, P type is a very thick. N type is consists of the electrons and P type consists of the holes. And here electron hole pairs can be generated when the sunlight is incident on the solar cell. Means voltage, current and power can be delivered by the solar cell. That is near about a 0.5 voltage can be generated by the single PV cell. Current can be 0.75 ampere and power near about 0.33 watts delivered by the solar cell. In the influence of the conditional of the sunlight, intensity, wavelength and angle of incident, these factors are very important for the generation of the power. And then we have to consider the visible bands gives the maximum power, condition of the junction and temperature, termination and external resistance are is very important. In the test condition, we have one more experiment of the solar cell in our laboratory. In that we have to consider how many components. One is the solar cell. We have to that solar cell directly incident a light, sunlight on that, and two terminals we have to connect it to millivolt and milliampere. They are interconnected to the external load. That is the variation of the knob is there, and the test condition we have to done by using the solar cell. How we have to use this solar cell? That is, solar cell is a specific particular reference condition, and with the help of VI characteristics, V is a direct voltage, I is the current, and power, that is we have to calculate it by using the formula PV. P is equals to what we have to say that VI. V is the voltage and I is the current. By using that formula we have to calculate the power by using these circuits. Now when external resistance R is a very high, like mega ohms. आपल्या लॅबोरेटरीमध्ये जे काही सर्किट आहे त्यामध्ये आपण जो काही लोड वापरलेला हा, that is R, it should be very high, near about the mega ohm. Mega means what? 10 to the power 6 ohm. Kilo means 10 raised to 3. Means we have to say that 10 to the power 6 mega ohm range मध्ये किंवा high resistance load असताना what will happen that when external resistance R is a very high mega ohm range condition, that is called as open circuit. How it is here? That is, R should be infinity. R should be infinity. Infinity means mega ohm range. At that time, resistance should be infinity. Voltage is maximum. That is, we have to get this point, POC, and that point is called as what? Open circuit. That point is called as what? Open circuit. When external resistance R is in the very high mega ohm condition is called as open circuit, and open circuit voltage is called as VOC, and solar cell it generates near about what we have to say that this is millivolt 450 to 500 इसके बीच में तुमको voltage मिलेगा. Means what we have to range, that is near about 0.5 volt and near about 4 से 50 millivolts or greater than that, near about 0.5 volt voltage can be generated. When external resistance R should be infinity, means value of R is maximum mega ohm range. At that time voltage should be near about 0.5 volt or 400 to 500 millivolts we have to generate it. And such a point, that point is generated on the x-axis, that point O, and that O point is called as what? Open circuit. This point is called as what? Open circuit. And at the same time, when the R is the maximum, voltage should be maximum. R is infinity, mega ohm range. Voltage should be open circuited, and at that time it generate how many voltage? 0.5 volt, and current should be 0. And current should be 0. And this condition, thereabout voltage is 0.5 volt. DC maximum voltage across the PV cell and open circuit current is 0. And that condition now open circuit current has to 0. Open circuit current is should be 0 at a particular point. See here, voltage should be maximum, that is open circuited. R should be infinity and current should be 0. After that, what will happen that is external resistance is a very high mega ohm and the range is, or it should be infinity. The external resistance R is reduced. How? Now we have knob is reducing 10⁻⁶ की जगह 5 करेंगे, 4 करेंगे, 3 करेंगे, किलो ohms में आएंगे, ohms में आएंगे. External resistance R is goes on reducing. What will happen that when R is goes on reducing, at that time we have to observe the graph, that is what DC voltage what we have to change. That is, if external resistance is reduced and the terminal voltage V and the load current I are taken, we get the VI characteristics. We have to measuring first of all how the resistance is goes on reducing. It is resistance can be goes on reducing. What will happen that V and I can be measured. Here we have to directly give the millivolts, and here we have current can be measured, and from this we have to graph can be plotted. Now measure the value, that is when R is goes on reducing, and then we have to get that as external resistance is a reduced from high value to low value, the terminal voltage of the cell falls and current is goes on increasing. Now see here, terminal voltage this goes on decreasing. Terminal voltage is goes on decreasing, and also current is goes on what? Increasing. Current is also goes on increasing. Here current is goes on increasing and voltage is goes on decreasing. When R is reduced, R is goes on reducing, external voltage is also goes on reducing, and current is also goes on increasing. Current is also goes on increasing, and external resistance is reduced, the low value, the terminal voltage of the cell is false and current is increased. A step characteristic is reached up to the point say O to S. Step characteristic is reached up to the point say O to S. The knee point K characteristics undergoes a smooth change and becomes a flat at the portion Ks. And here, this portion is what? Flat. I have that is a half portion. I have on this portion. Ks portion is a flat. Smooth characteristics we have to observe here. And then K point is called as knee point. जसं काय आपला गुडघा वाकतो तशा पद्धतीने आपल्याला वाकलेलं दिसलं आहे, म्हणून this point is called as a knee point. And when external resistance is completely shorted and short current ISC, and after that what we have to say that external resistance is completely shorted at the point say yes, when the external resistance is short circuited ISC is obtained, terminal voltage is short circuit is 0, and at a particular point when external resistance is 0, when external resistance is reduced to 0, what will happen that ISC short circuited and voltage should be 0. Short circuited and voltage should be 0. ISC is obtained. The terminal voltage of the short circuit is 0. Maximum current is delivered by the cell, and that current is called as say short circuit current. Maximum current is delivered. ISC, maximum current. Short circuit current is also called as what? Maximum current. This is what? Maximum voltage. VOC, maximum voltage. When R is infinity, VOC is maximum. When R is 0, ISC is maximum. When R is 0, ISC is maximum. When V is 0, R is infinite, maximum. And the circuit curve is almost flat between the knee point and the short circuit. here एक पॉइंट है शॉर्ट सर्किट में वो कैसा है फ्लैट है. Then solar cell is also called as a constant current source with the current output nearly equal to short circuit current. Constant current source. Solar cell is also called as what? Constant current source. Solar cell is also called as a constant current source, and current source output is nearly equal to the short circuit current, and preparing a point voltage VC, that is directed by the external resistance R, and current remains almost constant portion of say SK. This portion में current कैसा है almost constant आहे, then about 800 आहे, and such a portion is considered as a SK portion. And finally power can be calculated. Power can be calculated by the formula P is equals to say V into I. This formula is very important for calculating power from the solar cell. P is equals to say V into I. V is called as say PC and VC, and say also what we have to say that this is called as PC, this is called as VC, this is called as say IC. PC power of one cell, VC voltage of terminal cell, IC current delivered by the cell, power of a cell panel, array and module. Also one more formula for calculating the power, P is equals to also V square by R. This is second formula for calculating the power. Third formula also we have to say that also P is equals to I square R. This is the third formula for the power. By using these three formulae, we have to calculate the power from the any cell, and then power per module is equals to N into P. Power per array or panel is equals to N into P C. Power of solar panel by using this formula we have to calculate it. N म्हणजे number of solar cell, N म्हणजे number of module. Modules. PC and the power. Power per module we have to calculate it by using this formula. Then voltage across panel, PP is equals to PP upon IP. Current IP is equals to under root of PP divided by R. These are the very important formulae for calculating the power from the solar cell, and voltage and current can be calculated, and power per module can be calculated by using this formula. Voltage can be calculated by using this formula, and current can be calculated by this formula. These six formulas are very important in this chapter for calculating the power, voltage, current, resistance, and power per module. So VI characteristic is very important. Understand? And after that we have to solve some problems on this formulae of the solar cell. Thank you.